Welcome back. Today we're going to start section 5.1. We're going to start chapter 5 in essence, starting with 5.1. And 5.1 is defining rational expressions. Now please notice I have many of the notes already on the board, right? So I'm going to step out the way for a second. And you might want to go ahead and copy all the notes down first. Then I'll come back and explain and do a few examples. All right? So I'm going to move, pause the video, copy the board, and I'll be right back. Okay, here we go. I'm moving. Did you copy everything down? Okay, good. Let's get started. All right. So, 5.1. So 5.1 is defining rational expressions. So first, we want to let ax plus b divided by c be a rational expression. To be a rational expression, that means to have a polynomial divided by a polynomial. So we have ax plus b divided by c, two polynomials, where c is not equal to 0. Because if c equal to 0, we have no expression. We have no rational expression, definitely. We have nothing. It's undefined, all right? So, to determine all restrictions of ax plus b divided by c, determine all restrictions, determine all of those things that will cause this to be undefined. Those are restrictions. Here's what you must do. 3 things. 1, set the denominator equal to 0. That's c right here. 2, solve the denominator for all the given variables. In the denominator, solve the denominator. Notice I have not mentioned numerator yet. It's denominator and what? Denominator. 3, change the equal sign to a not equal sign. That means do what to the equal sign? Slash it. Put a slash right in it. Slash it like this. Slash it, right? Slash it. And that's how you determine all restrictions. Let's do some examples. Here we go. Example number 1. Determine all restrictions of 8x squared plus 2 equals divided by 13x. Let's follow the steps. Step 1. Set the denominator equal to 0. So then that means that 13x, that's the denominator, set it equal to 0. Step 1 is done. Check. Step 2. Solve the denominator for the given variable. When you see the word solve, that means that x equals blah. What does x equal? Solve it for x. X equals blah. Well, let's solve this. It's pretty easy. This is only a one-step equation, right? To solve this one, we're going to have 13x equals 0. Divide both sides by 13. The 13's go to 1. So I'm going to have x equals, and 0 divided by 13 is 0. That's it for step 2. We have solved it for the variable x. X equals 0. Step 2 is done. Check, check. Final step. Change the equal sign, which is right here, to not equal. So that means take your x equals 0 and put a slash in it, like this, not equal. That's it, ladies and gentlemen. This answer right here, this is the restriction. That's the final answer. X cannot equal 0. So that means that this expression right here can satisfy all values of x. X can be 1, x can be 1,000,000,000, x can be 1,000, x can be -6, x can be 11, x can be any value you want except 0. X cannot be 0 because 0 makes this undefined. That's it. Okay? That's the restriction. Let's do our next example. 6x squared plus 6 divided by 5x minus 6. Same process. All right. Determine all restrictions. Here we go. Step 1. Solve the denominator. Set the denominator equal to 0. Here we go. So we're going to have 5x minus 6, that's our denominator, equals 0. Step 1 is done. Check. Step 2. Solve the denominator for the given variable. All right. 5x minus 6 equals 0. Add 6 to both sides. I'm going to get 5x equals 6, and then divide both sides by 5. 5's cancel out here. I'm going to get x equals 6 divided by 5. Okay. Check. Step 2, done. Check, check, done. Last thing, last step. Change the equal sign to a not equal sign. So if we have x equal 6 over 5, if I put a slash there, that's the final answer. And this is the restriction. X can take on any real number values. X can be any number except for 6/5, because that's what would cause our denominator to be 0. And whatever makes the denominator 0 causes the expression to be undefined. You can't have 0 in your denominator. You know, you can't build on nothing, right? You got a 0 down there holding up everything. Really? We tried, but you can't build on nothing. Anyway, that's the restriction. Last one. All right. X squared minus 7 divided by 7x squared plus 5x. Step 1. Set the denominator equal to 0. Okay. 7x squared plus 5x equals 0. Step 1 is done. Step 2, we have to solve this now. Okay, I think I'm going to take it up here to solve it. Let's take it up. So we have 7x squared plus 5x equals 0. To solve this, we have to factor. Factor out an x, and we're going to have 7x plus 5 equals 0. And at this stage, look, if you notice, we have two factors. This was in our last lesson. All right, we talked about this in lesson 4.8, I believe. Here's one factor, and here's the other factor. You set each factor equal to 0. So you have x equals 0, or 7x plus 5 equals 0. Well, if I solve this one, if I subtract 5 from both sides, I'm going to have 7x equals negative 5, and then divide both sides by 7. 7's cancel to 1. X equals negative 5 divided by 7. And so there are your two restrictions right here. Notice this. We have x equals 0, and we have x equal negative 5 over 7. And when you have these two, do not forget to do the third step. Step 3. Which says change the equal sign to a not equal sign. So let's slash them both like this. Not equal 0, not equal negative 5/7. Those are the two restrictions in this case, two restrictions. X can be all values except x cannot be 0 and x cannot be negative 5/7. And that's how you find restrictions of rational expressions. That's part A. Okay? Any questions about part? Oh, I'm sorry. I'm asking questions. I can't hear you. My bad. All right, part B. But remember now, if you have any questions, you can text me, email me, or whatever. Okay? All right, B. Multiplication and division of rational expressions. All right, so if I have a rational expression, and if I want to multiply them, for example, if I have the expression A divided by B, that's one rational expression. multiplied by c divided by d. In essence, what you do is you multiply going straight across like this. Multiply going straight across. A times c is AC. B times d is BD. That's it. That's how you multiply rational expressions, straight across. Numerator with numerator, denominator with denominator. Where b cannot equal 0 nor d cannot equal 0. Again, we cannot have 0 in our denominator. In other words, these values of 0, that's the restriction. Hello. Those are your restrictions. Can't be 0 here. Okay? That's how you multiply. Division, you ought to multiply by the reciprocal of the second ratio. Well, here's the first ratio, A over B, and the second ratio is C divided by D. So you want to multiply by the reciprocal of our second ratio, which is C divided by D. Here's what it looks like. First ratio, first rational expression, A divided by B, and this quantity here, or this ratio here, is divided by the ratio C divided by D. Well, this is the same thing as A divided by B, which is the same as here, A divided by B, that didn't change, times, here comes the change. Okay, so the division now, the division symbol now becomes a multiplication symbol because you multiply by the reciprocal of C divided by D, which is D divided by C. That's the reciprocal. Because multiplication and division are inverse operations. To multiply by a number is to divide by its reciprocal. That's what it's saying in essence, right? It's like, let me give you a simple number. Like if I have the number 4, right? If I multiply 4 times 1/2, let's divide it. Let me divide it first. Let me divide it. If I want to divide 4 by 2, that's the same thing as taking 4 times 1/2. Because you know that there is a 1 under the 2. So multiply by the reciprocal. You know 4 divided by 2 is 2. And then you know 4 times 1/2, if I put a 1 underneath the 4, if I multiply going straight across, that's going to give me 4 over 2. 1 times 2 is 2, which is also 2. So dividing by 2 is the same as multiplying by 1/2. That's what's happening right here. That's the reciprocal operation right there. Okay? So here's what we're going to do. Here's going to be our process. So the first thing you're going to do, you're going to factor all expressions. That's 1. After you factor all expressions, 2, you're going to cancel. The reason we're doing these type of problems is for expressions to cancel. And you cancel numerator to denominator. Only. That's it. You never cancel numerator to numerator or denominator to denominator. It's numerator to denominator. In other words, you cancel top, cancels the bottom. Whatever on top, you can find where it can cancel on the bottom. Okay? Let's look at a few examples so we can have a better idea of what we're talking about here. So here we go. All right, away with all of this. All right. Okay, first example. Let's see here. Let's take a look at example 1. Simplify. Okay, we're going to have 4, or y rather, plus 4. Let's go start with that. Y plus 4 divided by y squared plus 3y minus 10 multiplied by y squared minus 10y plus 16 divided by y plus 4. Simplify. What is that going to give us when we simplify? Well, follow the two steps right here. Step 1, step 2. Step 1, factor all expressions. So first start with our numerator and the first ratio. Y plus 4, it's already factored. Just rewrite it like this. Y plus 4. Done. Divided by. Now let's factor our second expression in our denominator. Y squared plus 3y minus 10. Okay, we need two numbers that multiply to 10 and add up, negative 10 and add up to positive 3. What two numbers multiply to negative 10 and add up to negative 3? Positive 3. Well, we're going to have y plus 5 times y minus 2. Because positive 5 times a negative 2 gives us a negative 10, and yet a positive 5 plus a negative 2, its sum is a positive 3. So that's factored. Now let's factor our numerator on the other side here. What two numbers multiply to positive 16 and add up to negative 10? Well, let's try y minus 2 times y minus 8, all divided by y plus 4. Step 1 is done. Step 1 is finished. We have factored all expressions. The only reason we factor is for the factors to cancel. That's the point. That's step 2. You only factor to cancel. Now let's cancel. Alright, what can we cancel out here? Well, let's see. On top I have a 4, y plus 4 in my numerator. I have a y plus 4 in my denominator. You see that? That's that numerator to denominator relationship. One's up top, one's down bottom. Now, do you see this anywhere else? Of course you do. You see y minus 2, y minus 2. Anything else to cancel? Nothing left? Well, what's left over is the answer. So this is going to equal y minus 8 in my numerator divided by y plus 5 in my denominator. That's it. That's the answer, folks. That's how you do it. Okay? Let's look at another example. Example 2. Example number 2. Let's see here. What do we have for our second one? Okay, let's jump into division now. Let's go. X plus 4 divided by x squared plus 3x minus 10 divided by x plus 4 over x squared minus 11x plus 24. Now notice in this example, we don't start with multiplication, we start with division. So now we're going to use our division rule. Okay? So you take the first expression, the first ratio, and rewrite it. Which is going to be x plus 4 divided by x squared plus 3x plus a minus 10. Alright? And at this stage, very important, you make the division symbol here that divides the two rational expressions. The division now becomes multiplication. So now it's going to be times. and you have to take the reciprocal of C divided by D, which is going to be D divided by C. So flip it. It's a flip. Like you flip your flapjacks, pancake, yo, you pancakes, forget it. Flip it. So we're going to have x squared minus 11x plus 24 all over x plus 4. All right, reciprocal is done. Good. We got the reciprocal. So now, once the reciprocal is taken care of, start now with step 1. Factor all expressions. Let's factor it. All right. Let's move it over here. Let's move it up. Let's take it up a little higher, right here. I'm going to move it up now. Let's factor the expressions. So I'm going to have x plus 4. That one's okay. No factoring there. Divided by, we have to factor. Two terms that multiply to negative 10, add up to positive 3, should look familiar to you. We're going to go x plus 5 times x minus 2. X plus 5 times x minus 2 times. All right. Two terms that multiply to 24 add up to negative 11. And that's going to give us x minus 3 times x minus 8. Because negative 3 times negative 8 is positive 24, and negative 3 plus negative 8, their sum is negative 11, all over x plus 4. Step 1 is done. We factored everything. Now step 2, cancel out. What goes? What can we get rid of? The x plus 4s can go. Anything else? Nope, not at all. There's the answer. So this is going to equal x minus 3 times x minus 8 divided by x plus 5 times x minus 2. And there you go. There you go. Now, this also can be expressed, right, as a product. Right now we have it in factored form. Right? We have two factors in our numerator and the two factors in the denominator, but it can also be expressed as a product. So if you see it as, you know, as x squared minus 11x plus 24 divided by x squared plus 3x minus 10, well, it's the same thing. This is the same as, they're both the same, they're both equal. Okay? But I think you'd be okay if you leave it like this. That's fine. However, if you see it like that, don't be alarmed. It's the same thing. Okay? Let's look at one more example. Let's look at one more example. I think I'm going to need more space. Alright, I think I'm going to let this go. Alright, example number 3. Example 3. Okay, let's say in this case we have 5x squared minus 14x minus 3 divided by x minus 8 divided by x minus 3 over x squared minus 12x plus 32. Again, I invite you to pause the camera and try it on your own if you want to, without me going through it. So you can pause it now, see if you can do it. Okay? All right. Well, anyway, here we go. So I noticed that I have the division that's between the two rational expressions here. So I want to make that multiplication. So if I'm going to make it multiplication, then I have to rewrite the first rational expression, which is 5x squared minus 14x minus 3 divided by x minus 8. Got that, times, and write the reciprocal of this, which is x squared minus 12x plus 32 all over x minus 3. And now we have to factor. Step 1, factor all expressions. Step 1, we have to factor 5x squared minus 14x minus 3. Okay, so in order to do this, we have to go back and recall how we factored trinomials with the coefficients greater than 1. That was lesson 4.5 or 6, I believe. One of those two. Go back and check. All right, so let's just factor that. All right, so here we go. Let's take a look at that. How are we going to factor 5x squared minus 14x? 5x squared minus 14x minus 3, okay? Recall what we said when we factor these kind of expressions. All right, the first thing you need to do is to write two binomials, 5x, multiply 5 times negative 3. 5 times negative 3 equals negative 15. All right. Once you do that, we need two numbers. Give me two numbers that multiply to negative 15, and then two numbers that add up to negative 14. Two numbers that multiply to negative 15, because the first times the last is negative 15, but we did not use what's in the middle. Well, there it is right there, negative 14. So we used every term up here. Once you fill this in, drop those numbers right there. And we almost have it factored. Let's fill it in. What numbers multiply to negative 15 and add up to negative 14? How about negative 15 times 1? Negative 15 times 1 is negative 15. Negative 15 plus 1 is negative 14. So put negative 15 right here and put plus 1 right there. We almost finished, almost there. What can we factor out of this expression? Out of that binomial and get rid of? Factor out of 5. 5 times x minus 3 times 5x plus 1. And we get rid of this 5. And that's it. It's factored. So now we have the factors of 5x squared minus 14x minus 3, and it's x minus 3 times 5x plus 1. So let's write that. So now we have x minus 3 times 5x plus 1 over x minus 8 times, all right, two numbers that multiply to positive 32 and add up to negative 12. 8 and 4. So we're going to have 8x minus negative 8 times x minus negative 4 divided by x minus 3. There we go. So everything's factored. Step 1 is done. Step 2, what cancels out? What can we get rid of? Top and bottom. X minus 8, x minus 8, what else? X minus 3, x minus 3, and we're done. So our answer is what's left over. The answer is going to be 5x plus 1 times x minus 4. And that's it. That's lesson 5.1. One last thing I want to say is this. Let's say if you have an expression like this, for example. Let's say if you have 3x plus 1 over x minus 1 times 3x plus 1 over x minus 5. Okay? One thing you cannot do, you cannot cancel 3x plus 1 and 3x plus 1. That is a no-no. You cannot do that. That is a mathematical blasphemy. Can't do it. Okay? Because whenever you cancel, it must be numerator to denominator. You cannot cancel lateral. Numerator to numerator, or denominator to denominator. So this you cannot do. That is a no-go. In fact, since we can't do it, let's get rid of it. I don't even want to see it. It's not mathematically sound. Okay, that's it for 5.1. If you have any questions, issues, comments, cares, worries, concerns, woes, didn't get it, couldn't get it, redo, retry, do-overs, any issue, text me, email me, and I will gladly respond. Till we meet again, take care. Thanks for listening. Thanks for coming.